Tech in 5.
Dive into Python with a fun game, learn in just 5 minutes.
Welcome back to our journey of creating Minesweeper. Calculating the hints. Today's adventure takes us into the heart of Minesweeper, where each number holds the key to uncovering safe paths and hidden dangers. Join us as we break down the logic, step by step, transforming a mine-laden grid into a strategic puzzle waiting to be solved. In this update to our Minesweeper game, we're making a key change, using the grid itself to mark mines. This means each cell in the grid will directly show if it's an empty space or a mine. Let's walk through how we're implementing this. First, we initialize our grid. Each cell starts off as empty, indicating no mine is present. After selecting random positions for mines, we assign them on the grid. This step directly marks the mines on the grid, eliminating the need for a separate mine tracking system. To visualize the mines, we now loop through the grid and draw mines where they're marked. By directly integrating mines into the grid, we make our game more straightforward and maintainable. Next, we're diving into the core of the game's logic, calculating hints that guide the player through the minefield. Our first approach is straightforward, a brute force method that counts the mines adjacent to each empty cell. Here's where the magic happens. For each cell not concealing a mine, we find its neighboring mines. We scan adjacent cells, counting any mines encountered. This count becomes the cell's new value, transforming it from a mere empty space to a valuable hint. If a cell is surrounded by mines, its number reflects this, guiding the player's decisions. Cells untouched by the shadow of mines remain marked as empty, peaceful spots in the grid. As we loop through the grid in our draw method, we're now on the lookout for numbers. Each cell might hide a mine or hold a number, indicating the count of nearby mines. When we encounter a number, it's time to call the draw hint method. The draw hint method takes the screen, the cell's position, and the hint number. It then creates a text representation of the number, positioning it perfectly within the cell. This is done using PyGame's font rendering capabilities, ensuring the number is clearly displayed and centered in its cell. This brute force technique, while suits the classic Minesweeper game, is not the most efficient for larger grids. Another approach is to increase hint numbers simultaneously as we lay down each mine. This refined method plants mines and immediately updates the surrounding cells. As soon as a mine is placed, we look to its neighbors. If a cell is not a mine, we increase its hint number. If the cell was previously empty, it transforms into a 1. For cells already hinting at danger, we simply increment the number. This technique not only simplifies the logic, but boosts the game's efficiency. This approach transforms our grid into a detailed map of the minescape. With mines and numbers now visible, players have everything they need to strategically navigate the grid. To track whether a cell has been revealed in our Minesweeper game, we'll introduce a new grid with a flag to indicate the cell's state, hidden or revealed. Additionally, we will update the draw method to visually distinguish between revealed and unrevealed cells. Our draw cover method has been added to reflect this new dynamic. Unrevealed cells are now rendered with a 3D effect. This effect is achieved by drawing a rectangle filled with a light gray color, accented with lighter and darker edges to simulate depth. It's a simple yet effective way to enhance the game's interactivity and aesthetic. To enhance the gameplay and interactivity of our Minesweeper game, we're introducing a feature that allows players to mark cells with flags or question marks, in addition to revealing them. This feature provides players with tools to strategize and keep track of their deductions about where mines might be located. To implement this, we're renaming our revealed grid to Cell State Grid. Instead of tracking if a cell is revealed, we'll now track the state of each cell, whether it's revealed, flagged, marked with a question, or still hidden. Players can right-click to cycle through these states on each cell, adding a flag on the first click, changing it to a question mark on the second click, and returning it to hidden on the third click. Stay tuned as we dive into the code to implement these state changes in our next video.
Stay tuned for more videos on Tech in 5.